Welcome to section 7.3, Simplifying Rational Expressions. The essential question I want you to think about is how can we determine the excluded values in a product or quotient of two rational expressions? And if you remember, I introduced to you the asymptotes, which were lines that your function approaches but doesn't cross. Let's talk about a rational expression. It's a fraction whose numerator and denominator are non-zero polynomials. And the domain is going to be all real numbers, excluding values that make the denominator 0. So this section, we're going to introduce more values that are excluded other than just the asymptotes. First core concept, super easy. We've done this before. It's just simplifying or reducing fractions. So we have to divide out the common factors. What's key here is you have to remember only monomials divide out with monomials. Binomials divide out with binomials. That's why x plus 3 here can divide out. And then only trinomials can divide out with trinomials. A very common mistake is where kids think that in a binomial, the two x's can cross out, but that's not true. Each binomial has to be exactly the same. So let's do one problem here. Again, don't fall into the mistake that a lot of kids have where they think that they could cross out these x's, and that's completely wrong. So first we're going to factor this problem. What two numbers multiply to negative 12 and add to negative 4? That would be negative 6 and positive 2. And the denominator is going to be a dots problem, a difference of two squares, x minus 2 and x plus 2. All right, notice we have two binomials that can divide out. So we're going to go ahead and cross those out. And the answer is going to be x minus 6 over x minus 2. Now, the excluded values here, this is a new excluded value. X cannot equal negative 2. So what you want to think about is whatever you had canceled out, whatever is going to make that 0, so negative 2 plus 2 is going to make it 0. Same thing with the numerator, negative 2 plus 2 is going to equal 0. That is a new excluded value. When you move up in your math journey, you're going to see that these are going to be called holes when you graph the rational functions. And you can see that the asymptote here is going to be x equals 2. Okay, let's move on. Do a couple more problems. These can be done pretty quickly. Number 1 is already factored for you. You see that those cancel out. The answer is going to be 2 over x plus 3, but you have to include the excluded value. So x cannot equal negative 1. Going on to number 2, x plus 4, again, dots problem. X minus 4, x plus 4. These cancel out, but you have to remember there's always a 1 left in the numerator. It's going to be x minus 4, and the excluded value is going to be x cannot equal negative 4, because that's what's going to make that part 0. Okay, looking at number 3, already simplified. Nothing to divide out there. Okay, number 4. What two numbers multiply to negative 3 and add to negative 2? X minus 3, x plus 1 over, again, what two numbers multiply to negative 6 and add to negative 1? It's going to be x minus 3 and then x plus 2. You'll see that x minus 3 will cancel out. Answer is going to be x plus 1 over x plus 2. And don't forget your excluded values here. X cannot equal 3. Okay, let's move on to the second core concept. Multiplying rational expressions. Just like fractions, you just multiply the numerators together and you multiply the denominators. And from the polynomials and the exponents exponents that we've been practicing on simplifying, you just cross out or divide out any of the common terms. And this one, you do have to include the excluded values as well. So these are going to be x equals 0 and y equals 0. So there's going to be two of them. Okay, let's do a problem here. Okay, you see that. So since you're just multiplying the whole thing out, I would keep it in simplified forms. There are many ways that you can do this. You can multiply it out. I like to keep it in factored form and, written out. It's a little bit easier to see. But if you want to go ahead and multiply it out, you'll see this is 56, x to the 7th, y to the 4th. Don't forget there's a 1 there. And this is going to be 8x, y to the 3rd. Now you can reduce it. 56 divided by 8 is going to be 7. And I'm just going to write that fraction bar there. And if you remember your rules, there's 7 x's up here. There's 1 x down there. One of them cancels out. So it's going to be x to the 6th up in the numerator. And then for the y's, there's 4 on top. And there's 3 on the bottom. And the shortcut is where you subtract the exponents. And it's just going to be y. Now let's do the excluded values. Since we canceled out some x's here, and we canceled out some y, x cannot equal 0, and y cannot equal 0.